You can just put it into your pocket, it's not gonna fall out. And then this can go onto your, I think. Use your presenter mode.
Yes. Hello, good morning, everybody. First of all, thank you for the invitation to give a presentation here. So I will present the work of our PhD student, Pramita Fernando. It's joint work with VTT and UCD. And as already said, so Pramita received the Best Paper Award at IEEE CNS. So the paper is about securing xApps in Open RAN and mainly looking at authentication and authorization. So before delving in Open RAN, I was going to recap very shortly the 5G architecture, but we've seen it also in the previous talk, so I'll do it very shortly. So basically you have three different components. So on the one hand, you have user equipment, which are smartphones, IoT devices. Then you have radio access network, which basically is your radio base station implemented by the GNB node. And then this is connected with a 5G core network that is providing services like mobility management, session management, but also authentication. So security in 5G is actually pretty well defined. So we have the 5G ACA authentication. We have integrity protection for the radio interface. We have also several services or measures to secure the services on the 5G network. So that's all fine as long as you have one monolithic RAN. RAN thing, but if you, and this is the new trend, if you go like open disaggregated structure of your RAN, so where you have multiple vendors and you have disaggregated Open RAN distributed unit, Open RAN central unit, and an Open RAN radio unit, then the story becomes more complicated. And so that's why we now look also at the security of this Open RAN. So I also want a little bit to tell about terminology. So there are two terms that basically mean the same, but not exactly the same. So if you speak about Open RAN, then it's more the industry trend that's saying about open disaggregated networks. And when it's about O-RAN, then we refer to the O-RAN Alliance that is defining the specifications and implementations of this architecture. So for the Open RAN goals, so very shortly to recap, so main idea is that we have, as I said before, disaggregation of your radio network distributed unit and central units, disaggregation of hardware and software and multiple vendors that are included. We also work, like in 5G, on common on-the-shelf hardware, just to reduce the costs. If you have multiple vendors in your network, it's also important that the interfaces, that they are open and standardized. And so, yeah, also we have third-party applications included. So these third-party applications are developed by third-party developers. So that makes it even more challenging for the security management in the system. And they are designed for innovative services, being about optimization of your network or securing or other things. And the whole idea of this concept, Open RAN, is to reduce your costs, CAPEX and OPEX costs. Here you also see a figure of the architecture of Open RAN. So on the bottom, you have the radio unit and distributed unit, central unit connected by front haul and mid haul. And then two very important components are the near real-time RIC. So RIC stands for RAN Intelligent Controller, and then the non-real-time RIC. And in this near real-time RIC, you have these third-party applications. So it's called the xApps. And the same you have on the non-real-time RIC, there it's called the rApps. The difference is the time scale. So as the name is saying, near real-time xApps are applications with a time scale of 10 milliseconds to 1 second. When it goes above 1 second, it is located at a non-real-time RIC, and these are the rApps. Then furthermore, you also have the service management and orchestration, which has as main goal to be responsible for the life cycle of all these applications. It's also taking care of the resource allocation, configuration of the apps, etc. So you can see that as a single point of trust for these applications. Just also the slides to make a bit more clear difference xApps, rApps. I already said it's about a time scale. And because of this time scale, you also have different focus and applications of xApps and rApps. So xApps is really when it's real time. So it means real time optimization of the resources, balancing, mobility management. When all the things are not so real-time, optimization of energy management, it's on a longer term, a more deeper study of anomaly detection, and then it goes to the non-real-time applications. So the problem statement that we were working on in this paper was to look at the onboarding process of the apps, the rApps and the xApps, because what we could notice is that currently there's not so much attention to it. Either it is weak or it's not existing. Do it in a secure way. There is also currently no standard authentication and authorization mechanism. There is this ORAN Working Group 11 that gives high-level guidelines about it, but no concrete implementations. And then in literature, there is an approach proposed working on JSON web tokens. But then you have the issue of token hijackings and revocation issues. That's also where we propose two alternatives in order to make it a bit stronger. So the threat model in this whole story is as follows. So you have, we assume trusted entities being the parts of your network, radio unit, distributed unit, and central unit, and also the SMO. The untrusted entities are then these apps, applications that are developed by your third-party developers. You cannot trust them because there are just too many. You don't know who is doing it. They can be malicious, and because they are located inside these rigs, you can also assume that this rig is not fully trusted. And there can be passive or active attacks due to this malicious app. So you can eavesdrop on the communication that is in this rig and also actively tampering with messages sent in that. Okay, so for the whole approach of the onboarding, actually the architecture that we are looking at, or that we were proposing, was a hierarchical based approach. So you have 3 layers. So there is first in the non-real time, the rApp layer, then there is the near real time, the xApp layer, and then there is another layer which is for even more ultra latency applications. It's called the D applications. This is not in the standard yet, but you see it more and more coming up in literature. So that's why we included it in the approach. But the idea is that on every layer, you do the security control. You have dedicated security apps. And then there is one app that is collecting all information and sends it to the layer above where you have more resources and you can do, the latency is less urgent, and so you can do more in-depth studies. So that's the overall architecture. And then within this overall architecture, we were looking then at the onboarding process of the authentication and authorization of the apps. Here is the example of the xApps. It's exactly the same for the rApps and the dApps principle. We work with an XRF server, which is an xApp repository function. You can see it as the NRF entity in the 5G core, which is the kind of trusted entity that is offering actually the basis for the token generation. So when you just use JSON Web Tokens and you do not have any refresh mechanism, then every time that you have to change a token, you have to go through the whole authentication process. And in order to make that a bit more optimized, we propose to work with refresh tokens, because the idea is actually a token is valid for a short time, let's say 1 day, and then you have refresh tokens that have a higher validity, for instance, 3 days, 3 to 5 days. So yeah, the approach is pretty simple, I think. So the xApp is requesting at the XRF server the access token, then the access token and refresh token are sent. Yeah, and then when it's not valid, then you can send the refresh token back to the XRF server, and then the new access token together with the new refresh token is sent back. Now, there is also, yeah, once you work then with refresh token, this can also be stolen and reused, replayed, and then that's why we added an additional mechanism on top of it. This is then the token rotation to make sure that the refresh token can only be used once. Yes, so I need to speed up a bit apparently. So, and these things we also implemented then in 2 different architectural setups. So on the one hand, there is this local implementation where we have the XRF server consisting of OAuth2 and a database. In the near real-time rig, it's local, or we can send the same XRF server it's a layer higher, so in the non-real-time rig. And so we wanted to see what the impact is with respect to the latency on the position where you do this onboarding process. And then also we compared to 3, within these 2 setups, we compared to 3 approaches. So the one where you only have the JSON Web Tokens, the one where we use in addition refresh, and the one in addition the rotation. And as you can see, with respect to latency, actually, there is a difference between the setups, of course. So if it's local, and you see it's like 1/3 less efficient than more efficient than when it's non-local. And then within these 3 cases, then the difference is much smaller with respect to latency. Then we also looked at the consequences with respect to the network bandwidth. Here we have only the 3 cases to compare, so independent of where the location of the XRF server is. So this first situation, only JSON Web Tokens, there you don't have 2 additional phases being the refresh phase, so the request and response for the refresh phase. And so, yeah, so, and that's, yeah, and that gives you less bandwidth. For the other 2 cases where you have then refresh token and rotation, you have a little bit more bandwidth, of course, but what can be seen out of it, so it's just a matter of bytes, as you can see on the axis. It's not too much, so it's a very limited amount of additional bytes that yeah, that results out of it. So we could say that the impact is negligible, and also it's perfectly programmable. You know what to expect. Okay, so to conclude, we propose this hierarchical security framework. We improved the standard approach of this JSON Web Token with access with refresh mechanism and rotation mechanism. We also did the experimentation. It was just on simulation, so working with microservices. But from this simulation, we could see that the impact on computational and communication cost is kind of negligible. Future work that we would like to work on is mainly the inclusion of the post-quantum crypto in it, because, yeah, for the moment, we have done the implementation of this JSON Web Token approach. But in reality, these things are also incorporated in TLS tunnels. So we'd like to see what's the impact if you do then the post-quantum hybrid or not on the TLS tunnels. And also, in addition, integrated with this JSON Web Token approach. So that's one thing. And then it would also be super interesting, not only to test the things in simulation, but also to do it in a real network. And there we depend a bit on the on the testbed from UCD, that we can hopefully do the experiments in there. And then finally, also interesting is that we now gave like, we fixed the expiration time of the tokens and the refresh tokens. So it could be interesting depending on the security setting in your network to make this lifetime more adaptive. So that's it. Thank you very much.
Just before we go on to the break, I'd like to re-invite Rafael and just to take the photo, and also we have a small clip for you.
Are there any questions?
Oh yeah.
Yes, please. Okay.
Mention about that already very long when latency of authentications. So there, like how you are setting the how you are setting this authentication, and so is it a kind of threshold or any kind of fixed value you are taking, or how you are justifying this?
So you mean, so we were measuring the total time that it takes for this process over a longer period. So over a longer period, it means that you have to go over different refresh token and rotation token phases, and this all in one, to give average actually of the approaches.
And like change from xApps to RF to diapp, so that will change, right? So in your case, like, do you only show using the xApps, or you also will have done it for the RF and diapp?
No, actually, we only did for the xApps because, we wanted also to see the two scenarios where we have this XRF server at the local and then having at a layer higher, which if you do only for the RF, but of course the approach is perfectly possible for the RF, then you only have the second scenario. Just we wanted to understand what the impact is where you locate your XRF server. Yeah.
Yeah, very interesting. Is that going to, or do you see it maybe turning into technology that becomes the security layer for apps? So you'll have xApps and other apps with a diapp, and that basically means that that's the security aspect that it's taken care of. Separate abstraction layer. Should we see it as secure apps that are doing specific use cases?
Well, if you see here, I didn't show this picture, but here you see the diapps. You see on the second box, the diapps, they are also positioned at a different place in your network. So, yeah, exactly. So they have only, in fact, visibility on that layer. So it's all about, getting this local vision on the security. And then when it comes out of the time scale, it needs to go to the layer above and then again the layer above.